My name is Gokul Srinivas. People generally calls me Gokul. Today we are talking about this topic called scaling Kubernetes workloads in the smart way with KEDA. So I'm a senior DevOps engineer. I'm currently working with Hyundai Mobis. I'm working for the first Kubernetes project for Hyundai. So I take care of creating clusters and maintaining clusters, applications in it, maybe all the operations related to Kubernetes in Hyundai. So I just want to think you all like the applications running in Kubernetes. What if they predict the traffic that is going to hit applications earlier? Just like how we use Google Maps. If we are going from one place to another place, Google Maps, it shows that there is a traffic ahead and you can opt for another option, right? So in such way, what if applications running on Kubernetes can actually know the traffic that is coming before it hits? So, so this is where the KEDA comes in. So today the agenda is like we'll get to know what is KEDA and why it matters, how KEDA works, real world use cases, and also I'll give 2 live demos. And in the end, I'll accept. I'm open for all the questions from audience. So what is KEDA? KEDA, just like how we call Kubernetes as K it is a Kubernetes Event-Driven Autoscaler. In short, we call it as KEDA. Okay, so it is a CNCF graduated project. It allows Kubernetes workloads to scale based on external events, not just CPU or memory, where a traditional Kubernetes HPA works. So this extends that horizon. So yeah, why a traditional autoscaling falls short? Traditional HPA depends only upon the CPU and memory. I think those who are aware of Kubernetes, they know HPA, right? So HPA, it only scales applications based upon resources of the machine. So imagine, I think everyone uses Ola, Uber, right? So have you ever been into this situation? Like you have booked a ride, already the driver has come to you, and in the application, he's still half a mile away from you. Sometimes it happens, right? Don't you think Uber and Ola has enough resources to maintain their servers? No, right? There could be a situation where external events are affecting the application. Like the Kafka, suppose the Kafka topic, it has messages that are in queue, and Kafka producer is still producing the messages, and Kafka consumer is not. Yeah, so Kafka consumer is not taking the messages on time because of any reason. So the messages are piled up. But application CPU and memory are still, they are good. But because of this piled up messages, in the end, the user is getting impacted. Also, the businesses are getting impacted. So here is what KEDA steps in. Here is where KEDA steps in. It solves such problems actually. So yeah, as I said, it's Kafka. It works for Kafka, RabbitMQ, HTTP traffic spikes, and almost there are 70 plus triggers that KEDA works on. I'll explain. This is the KEDA architecture. So we have a scaled object where we define the KEDA, how it works and how the application should behave. We'll have to define here. We also have when we install KEDA, we get these 4 components: admission webhook, scalar, controller, and metrics adapter. So scalar basically fetches the external metrics or checks for the event triggers. Metrics adapter, it exposes the metrics to HPA. So you no need to separately deploy HPA. When you configure KEDA in your cluster, the KEDA itself takes care of the HPA. So whenever an application needs to come up, KEDA creates a HPA. It manages the application based on how we define. Okay? So yeah, again, yeah, as I told, it creates the HPA. HPA uses those metrics to scale the workloads. So yeah, so that's how we can, yeah, that is the KEDA architecture. Yeah, so scaled object. Whenever there is a spike is coming, it goes to the Kubernetes metric server. Then KEDA automatically tells HPA to scale up the pods as we define. So yeah, this is one more pictorial representation to understand. So yeah, there is a KEDA installed in the cluster. We can connect almost anything to KEDA. Like we can connect Prometheus. KEDA works with Prometheus metrics. It works with Kafka, Datadog, and almost all the cloud services supported by KEDA. Like yeah, yeah. So yeah, one framework, 74 plus ways to scale. KEDA supports 74 event sources out of the box now. So it's actively increasing the count still. I think 3 days ago it's 74. Yeah, we can scale Kafka message logs, RabbitMQ, Redis queue depth, yeah, Azure, AWS, GCP, cloud metrics, Prometheus custom metrics, whatnot. You name it, almost what we all use, what we have in the market. Almost all the scalars are with KEDA. It accepts HTTP triggers, cron triggers, and yeah, many more. I'll explain you like how it works in real time. Like I'll give you a demo now. So what we'll do, I'll give demo on two subjects, like one with cron schedule, another one with RabbitMQ queue length. We'll see how KEDA actually scale workloads on Kubernetes. Okay. So So this is very useful for the people who are working on Kubernetes. So I request everyone to see the screen. So yeah, so as I told, this is a cron-based demo. I'll show how a cron job can scale the pods in the cluster using KEDA. So we have a cron, we have a deployment file here. We have a service. We have a scaled object, which is the KEDA definition. I'll just show you what's in the deployment. So yeah, it's a basic deployment file. Like it is running with Nginx image. Yeah, under the cron demo namespace. Initially, when we deploy it will come with one replica. Yeah, so very simple deployment file. So I'll also show you just the service. Yeah, very simple service. Let's first deploy all these both. Yeah, namespace is not created yet. So we have created the namespace. Let's deploy the service. Yeah, service is deployed. We have also deployed this deployment. So yeah, so as we mentioned, a replica as one, the one pod has come up, a service has been created, deployment is running, replica set one, yeah. So let's see the scaled object.yaml now. So this is a scaled object.yaml. So here, as I mentioned, we are doing demo on cron jobs. We have pointed out the deployment name here. Yeah, scale target reference. Name is cron demo, which is our deployment name. And we are telling KEDA that the minimum replica can be 0. In traditional HPA, we don't get a pods to 0. It minimum should have a 1 pod running. But with KEDA, we can also make pods count to 0. So we are mentioning like it can go to the 0, and maximum replica count can be 4. And the trigger type is cron. Metadata like time zone, as we are in India, I mentioned Asia, Calcutta. And the pod autoscaling can be started, like I'll edit this. It's 1 o'clock now. I'm editing the hours and minutes. It's 1:13 now. Yeah, 1:04. And the desired replica should be 3. So what I'm asking is, like at 1:04, the deployment, the replica should be of 3, and at again 1:05, the replica should come down to 0. Let's see how it works. Yeah, before this, oh, it's already okay. Yeah, it's already 5 now. Let me use mic again. So I'm deploying the scaled object.yaml now. It's created. Let's see how the pods come up. Yeah, it's already 1.6, right? So the pod which is created in the first, that is created 5 minutes ago, newly 2 more pods they have come up, because the desired replica count we have mentioned as 3. So if we have any situation where we need pods to come up in particular time, we can use cron job. We can use that scalar with KEDA. Just like cron job, we'll also see demo on RabbitMQ. So it's 1.7, right? So now the pods will come down again. So it only serves in particular time that we mentioned, the pods. Yeah, let's not wait. It will come down. So yeah. So I'll deploy RabbitMQ deployment. Let's see what's there in the RabbitMQ deployment. So it's combination of few, like I've created namespace, a pod, a deployment, a replica is 0. Yeah, that's it. So from RabbitMQ deployment, we have got all this. Now let's deploy the scaled object. Yeah, sorry, before going into this, let's see what we have in the KEDA itself. So when we deploy KEDA, basically we get these 3 components. As we have seen admission webhooks, it is there, KEDA operator, and metrics API server. So these 3 take care of the scaled objects that we define in the cluster. Yeah, I forgot to show this before. Yeah. So in the KEDA scaled object YAML, we have this, like we have a secret, that's trigger authentication, and scaled object, and here the minimum replica is 0 and the maximum is 5. Yeah. So yeah, we have. Yeah, so we have created a scaled object for KEDA. This should probably increase the replicas of our RabbitMQ. pods. I have made some changes actually in the scaled object. Maybe that is the reason the pods are not coming up. Okay, yeah. So uh, the RabbitMQ, I'll have to troubleshoot it. Again, it takes some time. So we'll move forward. So what we have gone through cron-based scaling, before cron triggered activated, scaled workloads based on the time that we have mentioned. KEDA created a HPA only within the defined time that we have mentioned in the scaled object YAML file. So before cron, there were only 0 pods. During the cron, the pods were come up to 3. Again, when the time ends, the pods goes to 0 again. So zero resource wastage outside the cron schedule time. This is very effective for predictable and time-bound and workloads. This is what I assumed to create actually with the second demo, but that didn't happen unfortunately. Messages piles up. KEDA watches the queue length, just like Kafka that I tell you. KEDA tells Kubernetes to add more consumer pods based on how many messages are waiting. So more pods spin up automatically to handle the extra work. So that's how KEDA helps in such scenarios. So this is ideal for applications that process messages or tasks, scale your consumers when there's real work to do. No wasted resources. Just like how I told you, right, the Ola, Uber example. Maybe we can think in that way. So KEDA in a nutshell. KEDA makes Kubernetes event-driven. It unlocks the smarter auto-scaling. It supports 70 plus scalars, including cron, HTTP, Kafka, Prometheus, and more. Let me show you. These are the scalars, what KEDA supports. It supports more than 74. CouchDB, Cassandra, cron that we just did, etcd, Elasticsearch, GitHub Runner Scaler, InfluxDB, Loki, you name it what. Almost all the tools that we are using, they are in this 70 list. So it plays well with your existing Kubernetes cluster. You can install KEDA if you have Kubernetes. It runs on any cloud, whether it is EKS, GCP, maybe hybrid, also on-prem. So as a Kubernetes enthusiast, I am really excited about KEDA. So I also thought to share this with my fellow Kubernetes enthusiasts like you all. So explore yourself, like go to keda.sh, where you will get all the detailed documentations on every scalar they have. Maybe you can use it on a Minikube. Right now, I have shown demo on Minikube. So you can also try it by yourself, maybe like a simple cron jobs, etc. It's a CNCF graduated project. So I'm pretty much confident that we can also use it on production environments. Yeah. Yeah, don't just autoscale intelligently. Yeah, so yeah, let's scale the conversations beyond the pods too. I'm open for any questions, or else if you want me to connect on LinkedIn, you can find me on LinkedIn as Gokul Srinivas, my name. Yeah, if anyone want to share anything related to KEDA from audience, maybe their experiences, they can share. Or else, yeah, let's wrap up. Thanks, guys. Thanks a lot.